Hello folks, I just wanted to make a video to go over the undervolting method that I use for undervolting the Vega series of cards. I have a Vega Frontier Edition, but this should work for the other Vega devices as well. I believe that it will work with pretty much any card that has configurable states. These, if you go into the global Wattman and you see that you've got multiple states here that you can adjust, then this method should work for that. So what I'm going to do to demonstrate this is I'm going to go ahead and just reset the Wattman settings to their defaults. And in order to follow this method and run through the same process on your machine, you're going to need a couple of tools. You're going to need some way of monitoring the performance of your card over a period of time. And while Global Wattman does have a graph here, I find that it's better to use other tools where you can pull more information down. So what I do is I use HW Info. It's a free utility that you can download off the internet. You can set up graphs all over the screen and arrange them however you want. If you don't know how to create a graph from the list, you just find the value that you want to monitor. Say GPU core power, right click on it, hit show graph, it'll create a new graph, and you can move it wherever you want on the screen. It'll kind of snap to a grid here and allow you to arrange them nicely on the screen. But once you get that set up, you're going to want to get at least GPU utilization, GPU thermal diode, HBM temperature if you have HBM. Otherwise, you might just have other memory temperature in there for other cards. It helps to have the GPU fan recorded as well as your GPU clock and your GPU core voltage. You can also record your CPU usage and your CPU package as well. It's possible that if you run into some frame rate drops in the course of running your test, you might want to see if it correlates to, a period of high CPU usage or high CPU thermals. Anyways, going over this method, it's pretty straightforward, but trying to undervolt these cards by just looking at other people's suggestions on Reddit or YouTube is bound to cause considerable frustration. I know I've seen people, almost, to the point where they're pulling their hair out trying to get stability on their system because they'll get it where it runs okay, they switch to a different game, and the whole thing just falls over. One thing that I've noted is that the Vega, particularly the Frontier Edition, is incredibly finicky. If you don't go about this in a systematic way, you're just going to go insane trying to solve it. So let me show you what you'll need to do inside of Global Wattman after you reset this to default. By all means, save your current profile if you put a lot of work into it. I would assume it's already a profile, so you can apply it at boot up, but save that before you wipe it out. I'd hate to undo your other work. But anyways, after you've reset that, we're gonna need to set the power limit all the way up to 50%. The reason is that the card out of the box limits the total power output, and since we're going to be limiting the voltage, we're not going to be in a situation where we're going to put the card at risk. So we'll need to at least put this power limit up so that it can access the higher core speeds at the higher power states. Otherwise, you'll most likely run into a power limit, and that'll prevent you from having accurate testing. As far as your temperature targets are concerned, you can leave them as they are. What I found is that after running through a series of tests, I noticed that the HBM temperature was always a few degrees higher, and I did not want that hitting 85 degrees or exceeding that. And I found out that if I set this value to 76 for the target, it seemed like it kept the HBM memory below 85 regardless of what I did. What's important to note is despite the fact that there is a voltage setting here for the memory, it does not actually control the voltage on the memory. If you use other tools such as HW Info, you'll note that the that the memory voltage is always going to be 1.356. It doesn't change at all. So leave the memory settings alone for now. I know some folks want to set this up to a gigahertz or something like that. You can do that after you figure out your undervolt, your stable undervolt settings. But for the time being, just leave the memory alone. What you will need to do though is set a more aggressive fan curve. So what I'll do is I'll usually set the minimum to like 1,000 or 1,200, and the maximum is really up to you. It's a matter of personal preference. Depending on which card you have, you might have an aftermarket cooler, in which case it might be more efficient than the stock blower. Most likely it will be, unless it's a really horrible aftermarket cooler or a custom card. But the reference cards, they all seem to have the similar noise profile. Personally, because my desktop is a good distance away from me, I notice that the sound isn't horrible. Plus, I do a lot of work with my headphones on anyway, so it's not bad until it hits somewhere around 4,400 RPM. So personally, I set this to 4,200. You might find a different tolerance level here. All that's going to do is ultimately limit the amount of cooling you have, and it will limit the upper end clocks that you're going to have available to you. So just keep that in mind. It's always a trade-off. You're either going to have to deal with noise, or you're going to have to deal with lower clocks. If you're on water, obviously, you're going to disregard this. I don't think you're going to have Wattman controlling your cooling loop at all, unless you have a dedicated loop for it. But whatever you need to do, set that accordingly, or disregard it entirely. But in the case of air coolers, this is just a tolerance level that you're going to set. Anyways, I've wasted enough time talking about fans, so let's go ahead and move on to the meat of this procedure. On the Frontier Edition, we can modify all of the states here. So all of these power states that exist can be modified. I don't know if that's the case for the Vega 56s and the 64s. I knew at one time it was just state 6 and state 7 that can be modified. If that has changed recently, then that will make this process a little bit more flexible. Otherwise, if you've got a Frontier Edition, you have access to all of these, you can follow this tutorial exactly. Otherwise, you're going to just have to skip the state 5 work that I'm doing here and just move right to state 6 and state 7. Now, one thing that's important to note here is that it's not expected that your card is going to run in state 7 all the time. If that were the case, there would be no reason to have state 6 or state 5 or 4 or 3, etc. You would really just need a low-end state that you would have when your system's at the desktop or something like that, like it is right now. I mean, this thing's running at 74 megahertz, so clearly it's down in this area. But even when you're gaming, it doesn't make sense to have your card always in state 7, because if you've fine-tuned your state so that that's the maximum you can run your card at, your card's always going to be up against a thermal limit or whatever limit whatever limit caused that frequency and voltage setting to come into play. What you want to do, though, however, is ideally your card will run most of the time in state 5 or state 6. And you might be just doing, typical game functions. You might have an average number of polygons on the screen or average number of models loaded, and all of a sudden you turn a corner or something else happens, and now there's suddenly a much higher workload on the GPU. What you want to have happen is you want to have reserve so that the GPU will start working and be able to handle that sudden increase, which will most likely just be temporary, instead of always operating at this upper limit because of thermal limits, and then suddenly it can't do any additional work. That's when you have frame rate drops, and it gets to be really annoying to the average user. So that's something to keep in mind. So as you go through this process, don't worry about trying to get the highest possible clock out of state 5 or state 6. That's not the point of these states. You want to keep these more or less where they're at right now, and focus on state 7 for your upper end. That's where your benchmarking is going to, where your higher benchmark numbers are going to come from. But for typical game performance, you don't want to have all of these be the same. So for the purpose of undervolting, though, we do want them to be the same, and I'm going to go into an explanation real quick here. So you're going to want to turn the frequency to dynamic. Don't try to mess with the slider. It doesn't really give you fine-grained control, so just set it to dynamic and set the voltage control to manual. And what this is going to do is it's going to show you a baseline, the stock settings. So in this case, you can see that state 5 is 1442 megahertz. State 6 is 1527. And state 7 is 1602. Also on your voltage, you get 1105 or 1100, 1150, and 1200 respectively. Now, part of the frustration that people run into when they're doing their undervolting is when they have a crash. If you're running a stress test or you're running a game and you think that you've gotten everything ironed out and all of a sudden you have a crash, you don't know if it was in state 5, state 6, or state 7 when it crashed. And on top of that, these are not discrete states. These are just points along a curve. So the GPU doesn't just jump right from 1442 to 1527. It follows a curve, and it applies the voltage curve along that line as well. So part of eliminating that frustration is to eliminate the number of variables you have. You want to know what state the card is in when it either passes a test or it fails a test. And the way I do that is I look at state 5 in the case of a Vega Frontier. If you only have these two available, you're going to start out with state 6. So I look at the value that's here. It's 1442. I'm going to leave that alone, but what I'm going to do is I'm going to set the same value for state 6 and state 7. Now, the voltage settings here, as they are stock, are going to most likely cause thermal throttling. In this case, if I were to run the card in a stress test, it would go up this curve. It would see that it still has some thermal overhead, and even though the clock rate is not changing between these three states, the voltage definitely is. So as long as there is thermal room, it will just increase the voltage along this curve and get progressively hotter. So you're going to, at a minimum, want to step these all down to the same value as well. Now, you can just run the test like this and see if it's stable. It should be, because this is a stock setting, 1442 and 1100. So this should be fine. However, what you might notice is that it might get pretty warm because of this 1100 it's here. So what I'm going to do, just for demonstration purposes, is I'm going to go ahead and actually, since I know, yeah, I'll run it at 1100. Hopefully I won't crash the driver. So what I'm going to do is I'm going to use 3D Mark. Now, 3D Mark does have a free utility. I don't know what is available to the free users. I do have a paid one I got through Steam. So what I focus on is the stress tests. So I like to use the Firestrike Extreme. And what I'm going to do is I'm going to go ahead and run a stress test. Now, I'm not going to let this run all the way through. This is going to run 20 loops, and it takes about 10 minutes. What I will do, however, is allow it to run through 3 times, which is usually enough to get up to thermal equilibrium. And I think I forgot to hit apply here, so let me do that real quick. Now, of note here, when you do run the stress test in 3D Mark all the way to completion, you will be presented with a score. Now, a passing score is 97% or higher, And what you'll most likely find, and you're welcome to try it, is that if you take the out-of-box stock settings inside of Wattman and you run any of those stress tests, well, any of them that will get your card nice and toasty, you're going to find out that you'll most likely fail that test. I know for my particular setup, which is, I have a Intel i9 7940X, which is a 14 core / 28 thread CPU. I have all the cores running at 4.4 gigahertz. I have an Asus Rampage 6 Apex board with 16 gigs of RAM running at 3 gigahertz, and of course the Vega Frontier Edition. With stock settings inside of Wattman, if I run this particular test, I will get 87% thereabouts, which is a failing score. And the reason is because the card will just go balls to the wall. It'll try to hit those higher clock speeds. It will thermal throttle. It'll back off, and as the card gets hotter, it stops hitting those higher clock speeds as regularly as it was at the beginning of the test. And the way that that score is computed is it looks at each of those 20 runs. It gets a average frame rate for each of those 20 runs, and it looks to see if there is stability between the runs. If you get exactly 60 frames per second on all 20 runs, you're going to score 100%. If you start off with 60, frames per second, and thermal throttling kicks in, halfway through the test, and you're down to the 45, 50 range, you're going to fail that test. It's going to give you a bad score. Now, in this case, where I canceled it, like I did, it's going to show you a 0. But since you're running a stress test anyways, and you want to run it to completion just to be consistent, kind of keep an eye on that number. You'll find out that as you're doing this method, you're going to probably jump right up to a 99 or 100% just right off the bat because of the way this underclocking or undervolting method works. So that's kind of a thing to keep an eye on. If this number starts to drop as you start to get into the, tuning your your state 6 and state 7, it's probably because you're hitting thermal barriers and you're probably reaching a point of diminishing returns. So anyways, back to the results here. You can see that even though I only ran it for 3 or 4 loops, it did hit its thermal plateau. It hit 67C here for the thermal GPU. The HBM, like I said, it runs a little bit warmer. It shows up as 74, 75 degrees here, which is acceptable in my case. You'll see that the fan didn't really get up that high. It was only running at 827 RPM, and I received these temperatures at 827 RPM, or 828. So the card has plenty of room to work from this point. And you see the clock here. It hit the 14, about 1400 that we had specified. If I go back into Global Wattman, you see that I had a 1430 or 1442 dialed in. Now, it is important to note that there is discrepancy between what's in Global Wattman and what's reported in HW Info. I don't know if the card receives a different value or if the card just fails to execute these values properly, or if it's just HW Info has some kind of offset. But what I've noticed is it's always about 20 megahertz slower. Your core voltage is always a little bit different. Like in this case, it's 10, it hit 1050 right there, 1056. And, these are all set to 1100. So it never even got into that 1100 range. So there is a discrepancy there as well. What's important is not, what the value is, but it's the stability of this value. What you'll see is the clock here is pretty rock solid. It does not jump up and down. So that's what you ultimately want to keep an eye on. Now, that test completed just fine. And I can see that, my thermals were 73, 67 here. So what I know at this point in time is that this 1442 and this 1100 are perfectly stable. And not only is that setting perfectly stable, everything between this 1347 at 1050 and this 1442 at 1100 millivolts, everything along that curve is stable as well. As long as I've run adequate number of stress tests, I know that this entire range here is stable. So what I would do in this case, and in your case you'll want to follow suit, is take this voltage value that's here and start to drop it down. Keep running the tests. Keep an eye on it. Make a mental note of what or record it. Record what your temperatures are here as you start to drop these values. Now, what you're going to find is that as you drop the voltage, your temperatures might actually go up, and a lot of times that's because the fan itself will start to slow down because it doesn't see as much of a thermal load coming from the GPU. But because you cannot control the HBM voltage, and because we're not adjusting the HBM frequency, that thermal load remains constant. So because the fans drop off, you'll see an increased thermal reading from the HBM memory. And in addition to that, that thermal energy bleeds off into the GPU itself, and because it doesn't register the load, because it's paying attention to the clocks, the voltage, and also the temperature dial to some extent, it's not going to bump the fan up in response to that. So you'll see a slight increase on your GPU thermals as well as you drop your voltage. But you'll see that also that the fan's dropping down as well. So if the card needs to cool for some reason and it kicks the fan on, those thermals will drop. But it's perfectly normal to see those increase a little bit as long as there's a corresponding drop on the GPU fan. So what I'm going to do is I'm going to go ahead and load my current work in progress settings. And you'll see that in this case, what I've done is I've gotten to 990 millivolts. I'm pretty sure I could go lower, but I was already at the point where I was at a lower voltage than state 3 was by default, so there was really no point in me dropping this further, because what does not make sense is having a lower state have a higher voltage, because the whole point of dropping into that lower state is to cool the card off. And while there might be a frequency drop off, it's somewhat counteracted by having a higher voltage here. So what I did in my case, because I have the ability to adjust all of the states, once I found out that I could handle 990 millivolts at this 1452 frequency, I just propagated that backwards until the next value was lower. So this one I think was like 1 volt or something like that at one point in time. So I just went back and this value was lower, so I just left it alone. So that gives me better thermals up to this range, and I know that everything from here back is stable. So I've effectively locked in my state 5 frequency. I know that this setting is stable. It doesn't matter if it hits this setting in state 5, state 6, or state 7, the card is in the same condition, and therefore I know that it's stable. So the next step is to take this 1452 that's here and work with the stock value. Now, the stock value, I believe, is like 15. Let me reset the defaults here. The stock value is 1527, followed by 1602. So you can dial in a 1527 right off the bat if you wish. What I do, though, is I look at it as, I'm trying to get to that state 7 eventually. And if I'm going to have any level of overclocking here, I kind of want this to be a little bit higher. Again, I don't want to try to max this value. It does not make sense. Again, like I stated earlier, you want this to be the normal operating level of the card, but give you this, you want this to sort of be like the Intel Turbo Boost. It's there if you need it, but this should not be a steady state operation for your card, So what I'm going to do is I'm going to dial back in, let's see, 1527 is the default. I know I can handle 1532 at 1000 or at 1050. So I'm going to go ahead and do that. So now when I run this test, and if you have a card where you can only touch state 6 and state 7, then you'd start off at this state right here where you're setting a frequency and a voltage to test. And what you're doing is, in my case, I've locked into state 5, and now I'm focusing on state 6. I'm trying to find a stable value for state 6. And as long as the card gets up into this 1532 range and works reliably, then again, I now, previously I knew that this whole range was stable, and now I'm adding this range. I know everything in between these 2 points is stable as well. So I've already applied the settings. We go ahead and exit out of Global Wattman, and I'm going to run this test one more time. And again, I'm not going to run it to completion. And hopefully I won't have a crash, because that would probably cause havoc with my recording software. And I do have 2 monitors. Ideally, you'd have all your graphs and stuff moved over to a second monitor if you have one. But it doesn't make any sense for me to try to record this video across 2 displays. And, you know, deviate from the usual resolutions that you'd see for a YouTube video. So I got everything just running on the one display. And if you're hearing a loud noise in the background, I apologize. I work 24/7. I'm on call all the time, and that's my annoying ringtone to make sure I can hear when there's an alert, whether I'm sleeping or in another room. So I'm going to let this test once again run through 3 loops. I know from experience that running it through 3 loops is usually enough to hit thermal equilibrium on my machine. And your mileage may vary, obviously, if you're on a water loop. One disadvantage of water is that it takes considerably longer to reach thermal equilibrium. So that's something else to kind of keep in mind. And let's see, I think this is the second run, so I'm going to let it run through one more time. And then I'm going to look at my settings. Now what I've noticed is that when I run OBS to do my recording, sometimes when I escape out of the test, it'll just crash the driver. So I can have a stable test and, you know, run 20 or 30 tests, you know, at a given setting. But for whatever reason, when I have it recording in the background and I bounce out of 3D Mark, it has a tendency to crash the driver. That might be an indication that it's unstable at some level, but okay, I'll go ahead and stop it here. And again, it won't show me a score because I canceled it, but if you allow this to complete, you should get a score here. Alright, so going to my HBM now, I see that it hit 73, 74. The GPU maxed out at 66, which is fine. The GPU clock hit the about 1515, somewhere right around there. So again, it's about 20 megahertz lower than what I dialed in, which was 1532. It's not that the card's thermal throttling, it's just for whatever reason there's a misrepresentation like I mentioned earlier. And you can see the core voltage here is right at about 1 volt. So that does correspond with more or less what I had placed into Global Wattman. So I can see here that this 1532 1050 is most likely where it was operating here. What you'll note though is that it's now obvious that it's running in state 6 or state 7. It's not in state 5 anymore, because if that was the case, it would only be 1452 megahertz. So at this point in time, because this is really close to the stock setting, it doesn't really make any sense to try to bump the clock up. What you want to do is focus on dropping the voltage. So just continue to drop the voltage slowly. For both states, you want to drop 6 and 7 in this case. Run the stress tests. If you crash, bump it back up a little bit. If you pass, you can either run a test again just to make sure, or you can drop it by 10 10 millivolts, so drop this down to 1040 or whatever, or go in increments of five. Drop this down to 1045. If you're really trying to squeeze out performance, you can take it in smaller increments. But whatever you decide to do, just continue stepping this down until you find what's stable. In this case, I know that my particular card will run 1532 at 1012, and it'll run this just fine. I'm not gonna run through another test. This video is already getting kind of long. So once I run the test and validate that it works at 1532 and 1012, I've now locked in state 6 in addition to state 5. So now I know that this entire area here is stable. And now all it is left is just focusing on state 7. And this is the burst performance range of your card. You shouldn't ever expect your card to run here all the time, but you do want the card to be stable when it is in this area. So what you can do is, the stock setting here I think is 1602 at 1200 millivolts. So I know for a fact that I cannot run it at that. If I try to put 1602 here and 1200, it will just immediately reboot my system. It'll hard lock, or it'll trigger a driver reset. It just will not run with this card. So I can dial back the voltage a bit, and it will be more stable. But again, I have not completed the state 7 testing for this particular card. I'll probably leave state 6 alone. I haven't finished this. I could probably drop this down a little bit more, but I think this is sufficient because I still have some thermal overhead at this level. So pretty much just follow the same process. Once you've got state 6 locked in, focus on state 7. Once you get state 7 figured out and it's completely stable, run as many tests as you can, and just validate that it's working in that state. And once you've done that, you've gotten your card undervolted to probably the best of your capability. Also, because this is a procedural method, you start with state 5 or state 6 accordingly. You don't have to go through and do this in one sitting. If I was still working on state 5, for instance, and I had all three of these set to 1452 and 990, if I get tired of doing benchmark tests and stress tests, I can just leave them at that and just game at those levels, because for the most part, it will probably run better than the out-of-box settings at that level, because you're going to get a consistent clock. It's not going to be bouncing all over the place. You might not have as high of a peak frame per second, but your average will probably be better because you have better thermals. So you could just leave it at that partially tested state where you have all of these three at the same settings, and kind of give it additional validation. You can play different games, throw Doom on there, throw Fortnite or whatever you want at the card, and just see if it's stable. It should be stable, because most games are not as hard on the GPU as some of these stress tests. You can also throw Furmark at it if you want. I don't look at Furmark as being really a valid stress test. It's really a way of trying to make your card generate as much heat as possible, but it doesn't really do a lot of independent things inside the card. It doesn't really test a lot of the GPU functionality internally. So other tests might uncover stabilities, but Furmark is good just to see if your thermals are, your cooling solution is up to standard. So hopefully this will help you out. If you have any questions, feel free to post a question in the video. This is a new channel for me. I do have another channel where I post content, but I decided to start a new one just for gaming in particular. I do a lot of engineering and scientific stuff on my computer, which is one of the reasons I have a Vega Frontier in here. But I did see a lot of frustration online, and I know that I ran into some frustration when I started off with this card, so I figured I would kind of cover my method in a video just to kind of describe it. It's a little bit easier to do that than it is to try to describe it in text. So if you have any questions, if you get stuck anywhere, feel free to leave a question here, and I'll help you out to the best of my ability. Again, any of this is done at your own risk. And I'm a firm believer in putting the warnings at the end of the videos. But yeah, this is obviously at your own risk. It's not likely that you're going to do any damage to your card by messing with the settings in Global Wattman, but stuff can happen. So obviously, just be considerate of your card because you probably paid a pretty penny for it. And with GPU prices as high as they are now, right now, they are actually coming down as of the beginning of April. But it doesn't make any sense to kill your card outright. But this is a pretty safe method because you're really just starting out with your stock settings that are already tried and tested, and we're not overclocking the card. Really, all we're doing is dropping the voltage. We're undervolting it and improving the thermals. So until you get to state 7 here and you start bumping this up past your stock 1600 or whatever, you're not really putting any risk, or you're not really adding any risk to the card. So one more thing is, once you've gotten your state 7 locked down, you can start to mess with your memory. You can start to adjust this accordingly, because at that point in time you're not really dealing with any additional unknowns. However, it is important to note that as you increase the frequency here, since you don't really have any voltage control, you are going to put an additional thermal load on your system. And while the card may have been stable at these settings that you've dialed in, you may introduce instability with the extra thermal load. So that's something to keep in mind. You can kind of go back and forth on it, and you could kind of come up with an iterative process, but it is a lot of work. So I would probably just increase this slowly until I find a point where instability is introduced, and then you just back it down a hair just to make sure you're not running into that problem during the course of normal operations. So anyways, feel free to subscribe or thumbs up. Again, this is a new channel. I haven't really done any video processing or anything to this video to make it look professional. It's just, I'd rather get the information out to my viewers than make a artsy-fartsy video with a nice intro and everything, but that's probably coming, since I like to do some video work as well, especially with ray tracing and whatnot. So anyways, thanks for watching. And if you have any suggestions to improve this process, or if you found something that is actually more reliable, you think, in any way, post your methods in the comment, and I could possibly incorporate those values or cover that in an additional or in a follow-up video to go over the merits of that method as well. So hopefully this helps you out. Thanks for watching.